At the live stream, I will get some Dr. G fuel and take a sip, because I find that when I talk too much, it makes my heart rate go up.
Can you
That's
go over
something
the
I've
homework one
discovered.
more
If you
time?
talk too much, your heart rate goes up. Oh, did you have something you wanted to say, Geneva?
Yeah, can you go over the homework
Oh,
that's due on Monday
let me
one more
see.
time?
Oh, you want to put it in the chat? I can't hear you. At the live stream, I will get some Dr. G fuel and take a sip. Oh gosh, I'm hearing myself talk and I hate it. I hate it. Yes, we're going to talk about that today. So when we get to that task, I will tell you exactly what you need to do. And thank you for the reminder. Homework 5 is due on Monday. We are going to talk about that today. So I will tell you exactly what I would like you to do. All right. Okay, so last time we were here, we were talking about Mountain Dew and crackheads. Yeah, I know, really scientific, isn't it? Rather, we were talking about these different logical arguments and their validity. So we talked about 2 valid arguments. We talked about modus ponens. We talked about modus tollens. And we talked about 2 invalid arguments: affirmation of the consequent and denial of the antecedent. So here's something that's actually kind of interesting. Now, validity, remember, is all about the conclusion following naturally from the premises if they are presumed to be true. So for example, here's why denial of the antecedent is not a valid argument. So if you are a ski instructor, then you have a job. Okay, we're going to take that as true here. You are not a ski instructor. Okay, we're also going to take that as true. Therefore, you do not have a job. So this assumes that the only people that have jobs are ski instructors. So this is a denial of the antecedent. So remember that the first part of an if-then statement is the antecedent. The thing that follows the then is what we call the consequent. So if we're doing a denial of the antecedent, we're basically saying you are not a ski instructor. So the premise says that if you are a ski instructor, that you have a job. So it doesn't say anything about other people having jobs. It's specifically referring to ski instructors. So we don't actually know what the situation is for other types of jobs that are not ski instructors. So this conclusion does not naturally follow from the premises, and as such, it is invalid. Now, people have an easier time with denial of the antecedent than affirmation of the consequent. And part of the reason that I think people make mistakes and assume that these 2 are valid when they are not is because we assume that if means if and only if, or a very, very exclusive if. So if you are a ski instructor, you have a job. So we're only talking about ski instructors, but when people hear that, what they hear is if and only if you are a ski instructor, then you have a job, which means that anybody else who is not a ski instructor could not possibly have a job. So we assume that this if means if and only if, and that is not true. So here you can kind of see we have the endorsement of different conditional inferences. People are really good at recognizing that modus ponens is a valid argument. About 100%, almost 100% of participants do. Modus tollens is harder. A little over 50% get that. Affirmation of the consequent, people tend to believe that that's valid when it isn't, and about a good 30% do. Denial of the antecedent, maybe only about 20% do, which means to me that most people kind of recognize the denial of the antecedent is an invalid argument. Affirmation of the consequent is harder to deal with. So most of us are pretty good with modus ponens as a valid form. Modus tollens is a little bit more difficult. So this is a case of a context effect. And one of the things that we know is that in general, we are very greatly influenced by irrelevant contextual information. So things that are not and should not be considered part of a logical form are taken as an additional bolstering of the argument. So I'm going to show you an argument that was originally presented by Byrne in 1989, and the irrelevant information is in red. If she has an essay to write, then she will study late in the library. So this is our antecedent. This is our consequent. So here's the next part. If the library stays open, then she will study late in the library. So this is not relevant to the argument. She has an essay to write. So this is a modus ponens argument. So if she has an essay to write, she will study late in the library. She has an essay to write, therefore, she will study late in the library. Now, what's interesting is that people have difficulty when this irrelevant information is included, they have a greater difficulty endorsing the modus ponens argument, because now we've got this additional irrelevant information that in real life absolutely plays a role, but in terms of deductive logic, absolutely gives us nothing and is irrelevant. So extra arguments, people actually have greater difficulty evaluating this modus ponens argument and modus tollens when irrelevant information is included. We assume that this helps the argument when, once again, it is the form that matters, not the content. And you're like, congratulations, Dr. Gilchrist, you have effectively kept me, have now kept me from wanting to take logic at all. Do it. You'll learn so much and you'll feel so smart. That's not why you should take a class, but it helps. All right, everybody good? Okay. Ash, you good too? Okay. So counterexamples can often help us. So you are looking at, this is work from Denies and colleagues, in addition to looking at whether many counterexamples or fewer examples would help with different types of arguments. They also looked at working memory capacity. So remember that our low working memory span people have great difficulty with simultaneous storage and processing, and they have difficulty controlling their attention. People with higher working memory span are better able to control their attention. So here are our different arguments, and we're looking at acceptance rates. So counterexamples are basically, try to think of counterexamples to this argument. So let's go ahead and take a look at our high span participants first, and then we'll take a look at our low span participants. So the green bars are many counterexamples, the purple bars are few counterexamples. So notice that in general for our high span participants, their acceptance of modus ponens is pretty solid, regardless of whether there are many or few counterexamples. Modus ponens is probably one of the easier arguments to judge validity for. Now here's what's really interesting. Denial of the antecedent, or DA, which is an invalid argument form. Here's what happens to the acceptance rating when there's few counterexamples. If we have many, look what happens. The acceptance drops dramatically. So we get much better, our high span participants get much better at basically saying that's not a valid argument when they're given more information. Modus tollens is generally harder for people to accept, but in general, our high spans are accepting them at about equal rates. Interestingly enough, More information actually makes accepting modus tollens a little less likely, but that's probably not a very big difference. On the other hand, affirmation of the consequent, our high-span participants very quickly realize that it's not a valid argument the more information that they get. So here's our low span participants. So let's go ahead and take a look at their purple bars. In general, they're actually pretty good at identifying modus ponens and its validity. But if you give them more counterexamples, their acceptance rate of it actually drops. And that's true for our high spans too. Here, more information leads to less acceptance of denial of the antecedent. We get that with modus tollens and affirmation of the consequent. Now notice that really for the most part, the span groups really don't look all that different. Across both groups, you are less willing to accept invalid inferences with increasing knowledge. But in general, more information means you're also less likely to accept a valid inference. Look at this drop with both modus ponens for high span, modus ponens for high span, modus tollens for low span, modus tollens for high span. So in these cases, those are valid argument forms, but more information actually makes us less likely to accept them. That's kind of interesting. And just in general, the reasoning performance of the high working memory capacity participants is generally better than the lower group. But more information doesn't really, both groups do the exact same thing with more information. And that's kind of interesting. So here's the task that I want you to do. So we're going to do something. This is what's called the Wason card selection task. So I have 4 cards here. I have one that says R, G, 2, and 7. So the rule is this. If there is an R on one side of the card, then there is a 2 on the other. Which cards do you turn over to determine if the rule is correct? So go ahead and think about this for about a minute. If you're zooming in, tell me which cards you want to turn over in the chat. And if you're here in class, go ahead and write down which cards you would turn over. So we'll talk about how this works, and then I will give you your homework assignment. Okay, so let me see. KK. Okay, 1 and 2. What do you mean? You mean R and G? Do you mean R and G? It's easier if you refer to them by either turning over R, G, 2, or 7. Yeah, okay, so Tori says R and G. Anybody else? Okay, we got more in the chat. Okay, Maya says R and 2. Ava says R and 2. Geneva says R, G, and 7, or rather R and 2. Clelia says R and 2. How about over here? 2 and 7. Okay. You do R and 2? You can turn over as many as you want, but if you say turning over all of them, that's cheating. So you can't turn over all of them. All, okay. So which 3 would you turn over? Okay, 1, 2, and 3. So you turn over R, G, and 2. So if you want to figure out if the rule is correct, there's really only 2 cards you need to turn over. And so, and then 2. You're crafty, Geneva. You're crafty. You're too crafty, really. Okay, so she said I'd turn over 3, and then I'd turn over the last 3. Okay, so if you said that you need to turn over R, you're right. That is one of the cards that you need to turn over. So let's kind of talk about why you would need to turn that over. So one of the ways that we can kind of reframe this, and I'm going to go ahead and put this on stop share, and I'm going to do this on the board. So let's go back to our logical forms. Okay, so in this instance, we're basically saying if R, then 2, right? If R, then 2. So you're saying R, therefore 2. What argument form is that? We just talked, we talked about it. So if P, then Q, P, therefore Q, what argument form is this? This is a Modus Ponens argument, and this is logically valid. So R absolutely is one of the cards that we need to turn over, right? So here's the thing. Quite a few of you picked 2. Quite a few of you picked 2. You're saying that it would help you figure out the rule. Could you imagine a situation where you have a 2 on one side and something that's not an R on the other? Sure. But that's not enough to prove the rule. The rule is saying if there's an R on one side, there must be a 2 on the other. So picking R is important because if we have a 2, that proves the rule. If we don't have a 2, that disproves the rule. So if I turn over a 2 and it's got a G on the other side, that doesn't tell me anything about this rule. It doesn't disprove it. It's just saying it's a G on this side. It's not relevant to this rule. So what would we need to pick instead? If we want to either prove that our rule is correct or disprove it, you need to pick 7. Nobody picked 7, but here's why it's important. If I flip over 7 and there's an R on the other side, that means that the rule is incorrect. If I flip over a 7 and there's not an R on the other side, then the rule is still in play. So if I want to prove the rule is correct, remember, we need to be trying to disconfirm, not confirm. And in this case, you need to disconfirm. So if we think about flipping over a 7, the argument works like this. If R, then 2, not 2, therefore not R. What argument form is that? That is Modus Ponens, both of which are logical forms. So most people think they should pick R and 2. You actually need to pick R and 7. Now, here's where it gets kind of tricky, and I know why you might have had some trouble with this argument, because we're talking about very, very hypothetical rules about if you flip over this card, you get this number. And that's a little hard to kind of parse. But in this case, you should pick R and 7. Most people either just pick R or they pick R and 2. When you think about it in terms of the Modus Ponens argument and the Modus Tollens argument, it actually becomes easier. But in general, people have a better time with real world examples. So here's some of the reasons why. So one of the other big problems that we have is what's called matching bias. So when I tell you that if there's an R on one side, there must be a 2 on the other, in this particular instance, your mind becomes focused on R and 2. So you have a tendency to select the cards that are actually named in the rule, regardless of whether they are correct or not. So, so here's what's kind of interesting. So Ball and colleagues back in 2003 actually did a version of this task. And they had, and I'm going to tell you, and your book talks about this too, they actually reported what people picked based on the rule. So they kind of gave something very similar to me. The rule was if there's a vowel on one side of the card, there's an even number on the other side. So when they gave people the rule, if there's an A on one side, then there must be a 3 on the other. 87% of people took A. 7% of people picked J, which was one of the other cards. 60% picked 3. And then another 3% picked 7, another number card that they should have picked. When you get if E, then not 5. So if you pick E, there is not a 5 on the other side. 83% of people picked E, and 43% ended up picking 5. So we tend to select cards that are named in the rule. So here's the other thing that makes it the task is just too abstract. Wason and Shapiro actually found that when you talk about these hypothetical situations, it's a lot harder to process these. So one of the examples that we can actually talk about, so here's where the Wason task comes in. I'd like you to try to think of a concrete example that would make this task easier. So plug in different ideas, and I'm going to give you an example so that you'll know what to do for your homework. So when we talk about these hypothetical abstract situations with if there's an R on one side, there must be a 2 on the other, we tend to find that that's really abstract and it's kind of harder for people to parse. If, however, we put this in clearer terms, the task becomes much, much easier. So here's kind of an example. So one of the famous examples is basically drinking age. So I want you to imagine that you're like a police officer and you're trolling the bars to look out for underage drinkers. So I'm going to give you 4 cards. Okay. Okay, so I basically kind of changed this up a little bit, but here's kind of the idea. So my rule here is if you are over 21, you can drink if you are 21 and over, you can drink a beer. So we've made the task more concrete. The rule's pretty concrete. We have a drinking age. Underage drinking is probably not a good thing. And not to mention, you'll get in trouble with the law. So here, let's say that I changed my cards from letters and numbers into something like this. So I have one person who's 21. I have one person who's 18. I see another person who has a soda. I see another person who has a beer. Who should I check? Who should I check? If I want to prove if you're over 21 and over, you can have beer. I need to check the person with the beer to see how old they are. And I need to check the 18-year-old. Right? Does that make sense? Okay, so let's kind of put it in modus. So that may not have been the best formulation. Let me see if I named the rule the right way, because this is one of the classic examples. So I want to make sure I got it right. Wason beer selection. The Wason selection task. There we go. Okay. So actually, yeah, that's exactly right. So this was, so basically, if you are, actually, this is why I got the rule wrong. So here's the rule. If you are drinking alcohol, so if beer over 21, that's the rule. If you have a beer, you are over 21. That's the rule. So in this case, you need to check the person who has a beer, and you need to check the person who is 18. Does that make sense now? I'm like, that doesn't work in a modus ponens argument. So here's the modus ponens argument. We check the person who has the beer. If beer over 21, beer, therefore over 21. So that's our modus ponens argument. If P, then Q, P, therefore Q. We also need to check the person who is 18. So if beer over 21, not over 21. So this is our modus tollens, therefore not beer. So in this case, this is our modus tollens. If P, then Q, not P, therefore not Q. And both of those will help you figure out if that rule is correct. Now, does that make a lot more sense than the first task I gave you? And that's because when you put these things in concrete terms, it's much easier to follow. So your homework is to basically kind of create a real world version of this, just like we did here with the beer rules, and basically do your best to create it. Now remember that this is 10 points, so I'm not going to be like, this doesn't follow Modus Ponens perfectly. I want you to give it a try. I want you to give it a try. So you can either upload your own cards or pictures of cards, or you can simply choose to upload the 4 cards that you would use and what your rule would be. Does anybody have any questions on this? Does it make a lot more sense when I put it in these terms? And this example is so much easier to deal with than an abstract task like if there's a letter on one side, there's this number on the other. And yes, I am using it in that nerdy voice because I think it's funny. All right. So that was, by the way, this was actually developed by an evolutionary psychologist, Cosmides and Tooby, back in 1992. What's interesting, I think they are probably not from the United States because the example they have is if you're drinking alcohol, you must be over 18. And the drinking age has been 21 since like the 1970s here. Okay. So, yep, there it is. Whoops. Sometimes the board helps, but it's basically the same idea here. All right, here's where we get tricky. This is the part you may not like. We have to talk about syllogisms, or what is occasionally referred to as Aristotelian logic. So a syllogism are 2 categorical premises. So it will usually involve the words all, none, or some are not. So all, none, or some. And they'll typically be followed by a conclusion. So the premises will look something like this. All of the athletes are healthy. Some healthy people are wealthy. So the conclusion, some of the athletes are wealthy. So my question to you is this valid? So how many of you think this is a valid argument? Anybody think this is a valid argument? Oh, we got the chat. Okay, yes, it is actually not. So to kind of explain why, so it turns out, so I'm going to go ahead and open this hyperlink. So it turns out, and I'm not going to write all of these down, it turns out that there are 15 valid forms. This is not one of them. And actually, I found this earlier today. It's actually a computer program that judges the validity. So it's actually called an Aristotelian, I didn't spell it right, but the Aristotelian logic generator. So watch this. So all the athletes are healthy, enter. So that basically says all A are H, so all A are this class. Some healthy are wealthy. Therefore, some athletes are wealthy. Invalid. The middle term needs to be distributed in the premise. So the problem is we can't actually make the judgment call that some athletes are wealthy because some healthy people are wealthy, but that means that some healthy people are not wealthy and there's not an appropriate distribution there. Okay, so I actually kind of like this because based on this program, you can ask Aristotle. Oh gosh, I'm shaking and that's terrifying. Oh my. I don't think it likes it when I use this program because I was moving around there like this, like a little bit in the camera. But Aristotle in this program actually helps you figure out whether something is valid or not. So it turns out that once again, this is an issue where it's all about the form. So even though all athletes are healthy, only some healthy people are wealthy. This would actually work just fine if you said all healthy people are wealthy. But because some healthy people are wealthy, this implies that some healthy people are not wealthy. And thus, we can't actually make the conclusion that some of the athletes are wealthy. We can't make that conclusion. So how about this one? All the monks are men. No monks are women. Therefore, some men are not women. Who thinks this is valid? Who thinks this is invalid? Turns out it's valid. I am not kidding. So let's go take it back to Aristotle. Okay, Aristotle can help us. So I will go back to that form and it is in your textbook as well. So all the monks are men. Oh wait, all monks are men. Okay, so all M1 are M2. I guess they're putting it that way because they both start with M. The next is no monks are women. Therefore, that's valid. It is actually valid. Now, if you were taking a logic class, like when I took a logic class, we actually, this one is actually valid. If you learn how to map out a syllogism with a Venn diagram, this can actually help you. So I will actually try to map this one out because it's actually a little bit easier than the last one. So with a Venn diagram, what you're basically going to do is you're going to have two circles for the premises, and then you're going to have one overlapping circle for the conclusion. So we're basically looking for this overlap of three different circles. So here we have monks, here we have men, and here we have women. So these are our monks. These are our men. These are our women. So let's go ahead and put this on our Venn diagram. So all the monks are men. So basically what we are going to do is shade in all of the areas. So all the monks are men. So in this case, we are going to shade in all of this portion right here that overlaps with men. So all the monks are men. This is the portion that we fill in. Then we have none of the monks are women. So we're basically going to cross this portion out right here. So we're going to put an X there because that part is not included. So then some men are not women. So that's actually still, that would be this portion right here. This is actually in play, and because it has not been shaded out or blocked out, technically valid. Just trust me. There are 15 valid logical forms in syllogisms. This is just one of them, and you can learn more about those Venn diagrams if you wish, but here's my promise to you. I will not make you do this. I also will not have you judging the validity of an argument. But this one can be, even though it's not, it doesn't look valid on the face of it, it is. Right? Right. Somebody said, thank God. Yeah, I know. It's a little difficult to wrap your head around. And that's really what I'm more interested in. I am less interested in whether you know that these arguments are valid than I want you to understand why people might make mistakes in judging validity. This is not a logic class. I'm interested in how people think about these things. And part of the reason that syllogisms are so hard is because there is a huge difference between logical validity and standard validity. This is where we get into trouble. We don't really talk a lot about logical validity. And in general, when you hear a conclusion that's basically some men are not women, you're like, what? That is a weird conclusion to draw. And one of the things that we know is that really we should be paying attention to the content or the form of the argument rather than the content. But in general, we pay attention to the content far more than we pay attention to the form. So for example, that original one that I showed you, all the athletes are healthy, some healthy people are wealthy, therefore some of the athletes are wealthy. We believe that. We know plenty of athletes that are wealthy. We also know that they're healthy people. Even though it's not a valid form, this is a part of what we call a belief bias. I care more about you knowing what belief bias is and how it comes into play than whether an argument is valid or not. We have a tendency to accept believable conclusions, and we're more likely to reject unbelievable ones, such as some men are not women. And in general, we don't really pay attention to logical validity. So here we have syllogism type. So we have valid arguments that have believable conclusions. We have valid arguments with unbelievable conclusions. We have invalid arguments with believable conclusions, and we have invalid arguments with unbelievable conclusions. In terms of accuracy, what's really important to note, and we are kind of breaking this down by low and high working memory capacity, I want you to pay attention to the fact that by and large, regardless of whether you are low working memory capacity or not, note the comparison between a believable and an unbelievable conclusion. Notice that our accuracy is better when it's valid and believable than when it's valid and unbelievable. And that's true regardless of working memory capacity. Also notice that invalid believable conclusions are less accurate in their judgments. Like people have a harder time with this one when it's invalid and believable than they do when it's invalid and unbelievable. And that's true whether you have high working memory capacity or lower working memory capacity. In general, we focus much more on the content and we focus less on the form. So why does belief bias happen? That's because we use informal reasoning rather than logical reasoning. We're focusing more on how plausible something is in real life. Oops, sorry, I got a little too excited. Okay, so now we're going to talk just a little bit about theories of deductive reasoning. We will finish up logic and reasoning on Monday, and we'll start talking about language, and we'll finish up the semester talking about language in its various forms. So I think you're really going to like it. Okay. So one of the things that we need to talk about is the work of Johnson Laird. And basically, Johnson Laird basically says that when we are reasoning, that it actually works very, very similarly to how we would process language. So it basically means that anytime that we're looking at something that involves reasoning, we don't actually have a special part of our brain that is solely for logical reasoning. We basically are using very similar processes that we might do when we're trying to read. So it looks very similar to the kind of mental models that we form when we're trying to read. There's not like a special, this is solely rational thinking logical module. It's actually a mental model that we form when we read. We do a very similar thing when we are making or when we're trying to evaluate an argument. So a mental model, Johnson Laird basically defines this as a possible state of affairs on the world. And we're often going to focus more on what is than what is not. We're going to focus on what's probable and possible rather than what is not. So when I flip a coin, we generally know that it's either going to land heads or tails. That's basically two mental models that we have. There are only two ways that this can go. And so an example is kind of like this. The lamp is on the right of the pad. The book is on the left of the pad. The clock is in front of the book. The vase is in front of the lamp. Conclusion, the clock is to the left of the vase. And in your mind, you're probably constructing something that kind of looks like this. So how do we form these mental models? We usually do this with things like working memory. And generally, if we can't construct a mental model from the different premises, if we can't construct a mental model that basically allows the conclusion to be either true or false, we're basically going to assume that that particular model is not valid. And yeah, if you want to do some more fun with syllogisms, that website, by the way, was Aristotelian Logic Generator. I looked it up at lunch. It was fun. Aristotle does all the hard work for you. Okay, everybody good? Okay. So here are some of the major assumptions of these models. So we basically generate a mental model and potential conclusions like we did with the state of affairs of the clock and the vase and so on. And then we try to search for counterexamples to possibly falsify the conclusion. If our mental model is constructed in such a way that we can't falsify it, it's invalid. If we find that no counterexamples exist for our mental model, we are going to be more likely to determine that it's valid. It does require working memory. This is a limited capacity system. And additionally, we are going to follow what Johnson Laird called the principle of truth. We're only going to construct models about what is true. Another rule that your book talks about is what's called the principle of parsimony. And basically that's the idea that we're going to try to make as simple of a mental model as possible. Okay, so what evidence do we actually have for these mental models? Generally, because this is based on the work of a limited capacity system, because our capacity is so limited, that's part of the reason why the principle of parsimony exists. We don't want to get too complicated. If we have too many models, what we generally tend to find is that that's going to be very difficult for us to process due to our working memory capacity. And Copeland and Radvansky back in 2004 actually found that when you give people more of these mental models, it actually reduces their ability to reason well. So this kind of suggests that in fact, these mental models do require working memory capacity. And indeed, we do actually find that there is a moderate correlational relationship about positive 0.42. For those of you that are in my research methods class right now, you know that a 0.42 correlation for a psychology study is pretty solid. So we do actually find a significant positive correlation between working memory ability and reasoning ability. Now, something else, I kind of mentioned that that we're mostly going to focus on models that are true. And it turns out that there's a big difference between models that are based on possibility versus necessity. When we're talking about possibilities, we actually only need at least one good model, according to work by Bell and Johnson Laird. When we're talking about necessity, we need more proof. We need more evidence. And because of that, necessity actually requires many more models than possibility, where it could be true or not. If we're talking about necessity where it must be true, you're actually going to need a lot more information, a lot more evidence, and a lot more knowledge. All right, y'all, it is 1:50, so we're going to go ahead and call it a weekend. Don't forget about your quiz that we'll post on Sunday. If you have any other questions about the Wason task for Monday and you need my help, feel free to shoot me an email. Have a wonderful weekend. If you are traveling and heading home, be safe, make good choices. You know, don't lick doorknobs, and I will see you here on Monday and we'll finish up our discussion. We will talk a lot about logical fallacies on Monday, and I think that will be your favorite part of this lecture. No more Venn diagrams. Bye.